Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're going to be looking at Unit 7 on quadratic equations, Lesson 16, the quadratic formula. The learning goal for today is to learn a formula for finding solutions to quadratic equations. We have two learning targets in today's lesson, and when we get done with the practice problems, we'll come back and review these to make sure you understand everything you need to be prepared moving into future lessons. Learning target number 1 says I can use the quadratic formula to solve quadratic equations. Learning target number 2 says I know some methods for solving quadratic equations can be more convenient than others. As far as glossary terms go, we have quadratic formula, and they show the formula right here. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. To do this, we simply look at a standard form quadratic equation. We identify the a, which is the number with x squared, the b, which is the number with x, and the c, and then we simply substitute those in everywhere we see a, b, or c in the formula. This may seem kind of daunting at first, but aside from simply having a graphing calculator and being able to just type the equations in and let it do the graph for you, I actually prefer to use this quadratic formula rather than factoring or completing the square. I believe, and I hope you will too, that once you do this a couple of times, it really starts to make sense and it becomes a really easy process, and it works no matter how it is set up. Now we can begin with the practice problems for Unit 7, Lesson 16. The first practice problem says for each equation, identify the values of a, b, and c that you would substitute into the quadratic formula to solve the equation. What they mean by that is your standard form quadratic equation that we've talked about throughout Unit 6 and into Unit 7. Remember that it's ax squared plus bx plus c. So when you see them reference a, they are talking about the coefficient that is with x squared. So as we look through these, we're talking about the 3, the 2, the -9. We don't see one here or here, so they're talking about 1 and -1. When they reference b, they're talking about the coefficient that is paired with x. So as you look through this, they would be talking about positive 8, negative 5, positive 13. Here where we don't see it, it would be positive 1 and positive 16. And lastly, where they reference c, they are talking about the constant. So they're talking about positive 4, positive 2, negative 1, negative 11, and positive 64. So again, for number 1, we would say that A equals 3, B equals 8, and C equals 4. On number 2, we would say that A equals 2. We would say that B equals negative 5. And we would say that C equals positive 2. Number 3, we would say that A equals negative 9, B equals positive 13, and C equals negative 1. For number 4, we would say that A equals 1, because if you don't see a number in front of the variable, it is understood to be 1. We would say that B also equals 1, because again, if you don't see a number in front of the variable, it is understood to be 1. And we would say that C equals negative 11. And finally, number 5, we would say that A equals negative 1. Because if you don't see a number in front of the variable, it's understood to be 1. But if there's a negative sign there, then it's understood to be negative 1. Then we would say that B equals 16 and C equals 64. Now, I will mention, notice that every single one of these is set equal to 0. That's the first step. You have to make sure that the standard form equation is set equal to 0. The next thing I want to make sure I mention, it is not the order. The first number is not always A. The second number is not always B. And the third number is not always C. It is what they are attached to. So even if they rearrange the order, A is always the coefficient that is multiplying x squared, no matter where it is. B is always the coefficient multiplying x, no matter what order it's in. And C is always the constant that's by itself, no matter what order it's in. So step 1, make sure that it's set equal to 0. Step 2, make sure that you're not paying attention to order. Make sure you're paying attention to whether it's the coefficient with the x squared, whether it's the coefficient with the x or whether it's the constant that's by itself, then you simply identify the values for those three variables. If you have any questions about this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2 wants us to use the quadratic formula to show that the given solutions are correct. So I know that we briefly showed the quadratic formula when we were going through the vocabulary terms, but let me go ahead and write it up here at the top right so that you can remember it. It's x equals negative b plus or minus the square root of b squared minus 4 times a times c, and all of this is over 2 times a. So all we need to do is identify the a, b, and c terms, substitute them into the formula, and solve to get the answers. So on number 1, remember that the a term is the number with the x squared. Since we don't see a number, it's understood to be 1. The b term is the coefficient with the x term. So that means b equals 9. And the constant is the c term. That means the constant, or c term, equals 20. So now we can write the formula. X equals negative, substitute in 9 in place of b, plus or minus the square root of b, which is 9, squared, minus 4 times a, which is 1, times c, which is 20. And all of this is over 2 times a, which is 1. So now we have negative 9 plus or minus the square root. 9 squared is 81. Negative 4 times 1 is negative 4. And negative 4 times 20 is negative 80. On the bottom, 2 times 1 is 2. (81 minus 80 is 1. So now we're going to have two different answers. First, when we say that x equals negative 9 plus 1, because the square root of 1 is 1, divided by 2, negative 9 plus 1 is negative 8, and negative 8 divided by 2 is negative 4. And we can see that that matches the first solution they gave us on number 1. Then we would say that x equals negative 9 minus 1 divided by 2. Negative 9 minus 1 is negative 10, and negative 10 divided by 2 is negative 5. And that matches the second answer that they said we should get. So this shows that we properly used the quadratic formula. Number 2. We need to identify A, B, and C. A is the coefficient in front of x squared. Since we don't see a number, it's understood to be 1. B is the coefficient in front of x, so that would be negative 10. And C is the constant term, so that would be 21. Now we substitute them into the formula. X equals negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 21. All of that divided by 2 times 1. Negative 10 is positive 10. Negative 10 squared is 100. Negative 4 times 1 is negative 4. And negative 4 times 21 is negative 84. And that is all divided by 2 times 1, which is 2. (100 minus 84) is 16. And the square root of 16 is plus or minus 4. Now, to make this a little bit easier, I'm going to divide everything on the top by 2. So that's going to give me 5 plus or minus 2, because 10 divided by 2 is 5, and 4 divided by 2 is 2. So the first answer is x equals 5 plus 2, which is 7, and that matches the second answer they said we should get. The next is when 5 minus 2 equals 3, and that matches the first answer they said we should get. So this verifies that the solutions they gave are correct, because we got the exact same answers when we did the quadratic formula. And number 3, we need to identify A, B, and C. A is the coefficient in front of x squared, so A equals 3. B is the coefficient in front of x, so B equals negative 5. C is the constant term, so C equals 1. Now we fill out the formula. X equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times 1. And all of that divided by 2 times 3. Negative 5 is positive 5. Negative 5 squared is 25. Negative 4 times 3 is negative 12. Times 1 is negative 12. All of that divided by 2 times 3 is 6. (25 minus 12 is 13. Now, it may not look like it, but this actually matches the answer that they gave us. What they've done is they've taken the 5 plus or minus the square root of 13, and they've split it into two different fractions, both over 6. So they have simply rewritten this as 5 over 6 plus or minus the square root of 13 over 6. These both represent the exact same amount. So this is how we use the quadratic formula. We make sure that it's set equal to 0. We identify A, B, and C. We substitute those values into the formula, and we do all the math until we have the final answer. When we have rational numbers, we can go all the way to the answers. When we have an irrational number, such as the square root of 13, it's better if we just stop when we get to that point. Because if we try to calculate the square root of 13, it's an irrational number, so at some point we would have to round it. It's more accurate to just leave it written as the square root of 13. If you have any questions about any part of this practice problem, please leave a comment below, and I'll get back to you with any help that I can offer. Practice problem number 3. It wants us again to identify the values of A, B, and C that you would substitute into the quadratic formula to solve the equation. What's different about this one, as opposed to when we did it in practice problem number 1, is that now we have an equation that's not in the order that we're used to it being in. If you look at number 3, in number 4, we have the constant term on the right side, so we're going to need to move that to the left side so that it is set equal to 0. We're going to need to move the 121 in number 5 so that it is set equal to 0. And in number 6, we're going to have to move that 42 so that it is equal to 0. So let's make all the moves first, and then we'll talk about the A, B, and C. So if I look at number 4, I'm going to want to subtract that 1/3 from both sides. So this is going to become 4 over 5 x squared plus 3x minus 1/3 equals 0. Now we would be able to identify A, B, and C. For number 5, I like to keep my x squareds positive as much as possible, so I'm going to subtract the 121 to move it. So now I'm going to rewrite this as x squared minus 121 equals 0. On number 6, we need to subtract the 42 to move it over to the left side and set this equal to 0. So we'll have 7x plus 14x squared minus 42 equals 0. Now that we've set all of the equations equal to 0, we can begin identifying A, B, and C. The A term, again, is always the x squared. It does not matter what order they're in. It only matters that it's with the x squared. So those are all highlighted in blue. The B term is always the x term. Again, it does not matter what order they're in. It only matters that it's the x term. So these are going to be highlighted in green. And lastly, we need to identify the C term, the constant. Again, it does not matter what order they're in. It only matters that it is the constant. And I'm highlighting these in yellow. So, on number 1, the A term, because we don't see a coefficient with the x squared, it is understood to be 1. The B term, because it is the coefficient with x, equals 9. And the C term, because it is the constant, equals 18. These are the values we would use in the quadratic formula. Number 2, the A term is the coefficient with the x squared. So that means it equals 4. The B term is the coefficient with the x term. So that's -3. And the C term is the constant. So C equals 11. Number 3. The a term is the coefficient with the x squared. So a equals 5. The b term is the coefficient with the x. Since we don't see a number, but we do see a negative sign, that is understood to equal -1. And the c term is the constant. That means c equals 81. Number 4. The a term is the coefficient with the x squared. So a equals 4 over 5. The b term is the coefficient with the x. So b equals 3. And the c term is the constant. That means c equals -1 over 3. Number 5. The a term is the coefficient with x squared. We don't see a number. It is understood to be 1. b is the coefficient with x. There is no x term in number 5. That means b equals 0. And the c term is the constant. That means it equals -121. And finally, number 6. The a term is the coefficient in front of the x squared. That means a equals 14. The b term is the coefficient in front of the x term. That means b equals 7. And the c term is the constant. That means c equals -42. So a couple of takeaways from this practice problem. Number 1, you must set it up so that it is equal to 0 before you identify a, b, and c. Once it is set equal to 0, remember, it is not the order that makes it a, b, and c. It is a is always the coefficient with x squared. B is always the coefficient with x. And c is always the constant that is by itself. Order does not matter. If you still have any questions about any of these practice problems, please leave a comment below and I'll get back to you with any help that I can offer. Now, before we finish this video, let's go back, review the learning targets, and ensure that you have learned everything you need to before we move forward to the next lesson. Let's review the learning targets from Unit 7, Lesson 16. Learning target number 1 says that you can use the quadratic formula to solve quadratic equations. This means you understand that the first thing you need is a standard form quadratic equation that is set equal to 0. Once you have this, then you need to identify the A term, the B term, and the C term. Remember that it is not about the order. The A term is always the coefficient with x squared. The B term is always the coefficient with x, and the C term is always the constant. Once you identify these three values, you're simply going to substitute them into the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, and all of that gets divided by 2 times a. Substitute the values in, complete the math, and you find your answers. Learning target number 2 says that you know some methods for solving quadratic equations can be more convenient than others. So at this point, we've talked about 4 different methods. The first one was graphing. If you have a graphing calculator available, and if you're allowed to use it, by all means, type in the equation set equal to 0, let it draw the graph for you, and then understand that your solutions are the x-intercepts. The second method we looked at was the factoring method. You make sure that you either have a factored form quadratic equation, or you rewrite it into a factored form quadratic equation. You make sure that it is set equal to 0, and then, because of the zero product property, you set each factor equal to 0, solve for x, and you'll find your solutions, which will be your x-intercepts. The third method that we looked at was completing the square. If you happen to have a quadratic equation that is already a perfect square, then this method is very quick. You take the square root of both sides and solve for x. If what you have is not a perfect square, then first we need to complete the square, which means we have ax squared on one side plus bx, and then it's set equal to something on the right side. We take the bx term, we divide it by 2x. That's going to be our term 2. Then we take that term 2 and we square it, and that gives us the c term that we're going to add to make it a complete square. We ensure that we do that on both sides of the equation. Then we can rewrite the left side as the factored form or vertex form, perfect square. And once we have that, now we have completed the square. We take the square root of both sides and solve for x. And now today we find the quadratic formula method. I personally prefer to use this formula because it works for all quadratic equations and it's straightforward. Set the standard form equation equal to 0, identify a, b, and c, substitute them in, and do the math. So hopefully you understand multiple methods. You understand when it's a good idea to use them, when it might be a better idea to use a different form. But in the end, I hope you feel confident in your ability to solve quadratic equations. If you have any questions about anything we've covered, please make sure you leave a comment below, and I'll get back to you with any help that I can offer. In the bottom left of the screen, you should see a video that YouTube believes you will find helpful. In the bottom right of the screen, you should see the subscription button for this channel. If you find this content helpful, please hit the subscribe button, give this video a thumbs up, and I look forward to seeing you in the next lesson.